everyone! Today we're tackling a basic calculus problem, the sliding ladder. A ladder 32 foot long is leaning against the wall of a house. The base of the ladder is moving away from the wall at the rate of 2 foot per second. And we have to answer two main questions. Letter A. At what rate is the top of the ladder sliding down the wall when the base of the ladder is 16 foot from the wall? And letter B. At what rate is the angle measured by the ladder with the ground changing when the upper end of the ladder is 10 foot from the ground? We have a 32-foot ladder leaning against a wall. The base is sliding away, and we need to find out how that affects the height and the angle. So let's start by setting up our variables. Since the ladder, wall, and the ground form a right angle, we use the Pythagorean theorem. X squared plus y squared is equals to 32 squared. We're told that the base is moving away at 2 feet per second, so our rate of change for x or dx over dt is positive 2 feet per second. To find how the rates are related, we take the derivative of the whole equation with respect to time using the power rule and chain rule. D over dt times x squared plus y squared equals d over dt times 32 squared. This gives us 2x dx over dt plus 2y dy over dt equals 0. We can simplify this by dividing everything by 2. And we will get x dx over dt plus y dy over dt equals 0. This is our master formula for the rest of the problem. Solving for our first question, letter A, we need to find dy over dt when x is equal 16. So part A asked for the rate the top is sliding down when the base is 16 feet from the wall. But before we plug in our rates, we need to know the height or y at this exact moment. So solving for y, we have 16 squared plus y squared equals 32 squared. This will give us y equals the square root of 32 squared or 1024 minus the square root of 16 or 256. This will give us the square root of 768, which is equals to 27.71 feet rounded off. So using the Pythagorean theorem again, we find that when x is 16, y is approximately 27.71 feet. Now let's plug everything into our master formula. 16 times 2 plus 27.71 times dy over dt plus 0. This will give us 32 plus 27.71 dy over dt equals 0. And it will become dy over dt equals negative 32 over 27.71, giving us negative 1.15 feet per second. We solve for dy and dt and get negative 1.15. The negative sign is key. It tells us the top of the ladder is moving downward at 1.15 feet per second. Now for part B, we need the rate of change of the angle theta when the top is 10 feet from the ground. We'll relate x and theta using cosine function. Cosine theta is equals to x over 32. Differentiating both sides gives us negative sign theta times d theta over dt equals 1 over 32 times dx over dt. And now getting d theta over dt is equals to negative 2 over 10. This will give us negative 0.2 radians per second. We find that the angle is changing at negative 0.2 radians per second. The angle is shrinking as the ladder falls flat. And there you have it. You've finished the problem. Our final answers, letter A, dy over dt equals 1.15 feet per second, and letter B, d theta over dt is equals to negative 0.2 radians per second. Related grades are all about finding the static equation first, then differentiating to see how the movement of one part affects the rest. Thank you for watching!